Hello, everyone. Today is March 13th. This is Working Group Batch, and we have gathered here to discuss some of the agenda items that we have for today. I see King is on the call. I believe you have an agenda item. You want to go ahead? I gave you already co-host, so if you want to present, you should be able to.
Hello, thank you. Let me share my screen. Okay. Oh, can you see my screen?
Yes, we can.
Okay, thank you. Okay, hello everyone. I'm Haqing from the Red Hat, and I'm also the maintainer of Open Cluster Management community. And today I want to introduce about the OCM.io and how we do the integration with multi-queue. The background is that last year we have a Google Summer of Code project, and the title is Scheduling AI Workload Among Multiple Clusters. And in that project, we integrate OCM with multi-queue. And today I want to do an introduction to this and do a demo and want to know your thought and feedback. Okay, first of all, the open cluster management, we focused on multiple cluster management, and we focused on to simplify the fleet management across the open hybrid cloud, and it's a hub spoke architecture, and we have 4 core concepts. For the cluster inventory, a user can register multiple clusters to the hub and to place them for management. For the workload country distribution, the workload API enables users to apply their resource to the managed cluster from hub. And for the content placement, user can dynamic place the content and behavior across multiple clusters. And last is we have add-on extensibility, or we have add-on framework that provide an integration point to make Kubernetes capabilities to multi-cluster aware. And at last is that we are vendor neutral APIs so that user can avoid vendor locking by using the APIs. And also we are a CNCF project. This is our website. And for the integration part, I want to talk about 2 benefits we hope we can bring to multi-queue. One is we simplify the multi-queue setup, and also we want to enhance the multi-cluster scheduling capabilities. And first, let me show how we can help to simplify the multi-queue setup. In this picture, you can see the blue part are the queue and some configurations of queue, and the purple part are OCM and that are installed both on hub and the managed cluster. And the cluster profile is an API from the Sigma multi-cluster, so I mark it as yellow. And when the when the managed clusters are registered to the hub, the OCM will generate the credentials and kubeconfig automatically, and all the result will put to the credential field in the cluster profile. And with this, for multi-queue users, they don't need to manually create the kubeconfig anymore, and they can just reference the secret name in the multi-cluster config, so that we can help to simplify the setup. This part is easy to understand. Next is how we enhance the multi-cluster scheduling capabilities. As I talked in the first page, the placement is a concept in OCM. In placement, the user can define some strategies to select clusters. For example, they can define some label selector and some taint toleration or some prioritizers to sort the cluster. And all the scheduling results we put in the placement decision. And in our GoSock project, we implement an external automation check controller based on the placement. And with this implemented, for the multi-queue users, they don't need to manually create the multi-queue config and multiple cluster anymore. Or for example, this is how they can define their cluster queue. Or they have to define two automation check. One is the automation check for multi-queue, and another is for the placement. In the multi-queue automation check, they have to define the multi-queue config name, but they don't actually need to define the results because this will be created by OCM. And in the placement automation check, they need to define the controller, point to the placement from OCM, and also in the parameter, they have to reference the placement resource name. And with this defined, the external automation check controller will read the clusters from the placement decision and generate the config and multiple clusters for queue users. And also for OCM, our placement results can be changed dynamically. For example, if user want to select a cluster based on the available memory, available CPU or GPU, when the resource changes, available resource change on the clusters, the result can update dynamically. And for the integration, when the decision changed, the OCM will also update the multi-queue config and the clusters dynamically. So that we think there are two meaningful cases. One is with this integration, user can place the AI and machine learning job on clusters with specific GPU type. And also user can place the job based on cluster available GPU dynamically so that can increase the resource usage and reduce the resource fragmentations. And issues for this, and next I want to do a demo. Okay. Next, I will do show three demos. One is how we simplify the setup, and another two is for the scheduling. This is one topic we did on the KubeCon of last year. Okay. So first, in this environment, we have one hub and three managed cluster installed. And we also installed queue on these clusters. You can see the hub, both the hub and managed cluster has queue installed. And also OCM has an integration with the cluster profile API from Sigma-Multi-Cluster. So you can also get the cluster profiles. And you can see once the cluster is imported, the credentials are created automatically by OCM. Both of the three managed clusters have the credentials created. And we create a namespace under Q system namespace. And then in the multi-queue setup, user can use this secret directly. We check the multi-queue cluster conditions. It made a few seconds to update. Yes, all the clusters are connected. And also the automation check conditions are good. And also the cluster queue said it can admit new workload. And next we will create a job to this queue. And you can see it's scheduled to cluster 2. It means the credential works. Okay, this is the first demo. Next is about the scheduling part. First is we want to deploy the queue's workload on clusters with a specific GPU type, NVIDIA Tesla T4. The environment is same as the first one. I will skip this check. We have 3 managed clusters and cluster profile contains the credentials. And only cluster 2 and 3 have 3 GPUs with type NVIDIA Tesla T4. You can see cluster 2 and 3 have 3 GPU. And then we will create a placement to select these clusters. With GPU type NVIDIA Tesla T4, we define a label selector in the placement. And in OCM, we need to band the managed cluster to a specific namespace. Here we band it to Q system namespace. And then we create this placement. Can check the decisions. You can see this placement is placement demo 2 and it select cluster 2 and 3. And then we can use this placement to create the multi-queue environment. We have a cluster queue, local queue, and in the automation check, you can see we define 2 automation check in the cluster queue, and we have 2 automation check, but we don't define any multi-queue config or multi-queue cluster. And once we create this resource, the OCM external automation check controller will create the multi-queue config dynamically and also put the decision to the cluster list and also generate 2 multi-queue cluster resource. And also the credentials are put in the resource. Let's check the automation check. I think all the automation check are active. And the cluster queue is also active. Then we can try to create a job to this queue. This job requires a 1 GPU. Or you can see it is scheduled to cluster 2. Okay, this is the second demo. Third demo is based on the second demo, but we want to show how the decision update dynamically based on the resource usage. So to check the resource usage on each managed cluster, we developed a resource usage collect add-on, which is deployed on each managed cluster. And it will check the available GPU and give each cluster a score. And in placement, user can select a cluster based on these scores. First, let's check the resource usage add-on agent. It's an agent installed on each managed cluster. You can see this is a concept from OCM. They are installed on cluster 1, 2, 3. And on each managed cluster, there is a agent pod running actually. And for clusters, if they have more available GPU, it will have a higher score. This job is what we run in the second demo. You can see this job is running on cluster 2, and cluster 3 has no job. But since cluster 2 and 3 both have 3 GPUs, so when we check the score, you can see cluster 1 is negative 100 score because it don't have a GPU, and for cluster 2 and 3, cluster 3's score is higher than 2 because 2 have already used the 1 GPU. And now we can update the placement in the second demo to let it select the cluster with the most available GPU. We can reference the score in the placement. And with this defined, the placement decision will update dynamically. You can see now only cluster 3 is selected. And when the decision changes, the multi-queue configs will also update dynamically. You can see now the multi-queue config only have cluster 3 in it. And at this time, if user create a new job, it will create to cluster 3. Yeah, you can see the new job scheduled to cluster 3, so that each cluster have a job running now. Okay, that's a demo. And also there are some links for our GoSock project and our solutions and some presentations in KubeCon. And I think that's all for my presentation. Any questions?
I see Marcin has a question.
Uh, Thank you for the demo. It looked really nice. I have a questions about next step. Is the setup somehow documented on the open cluster management side? If yes, could you also add it on the queue side so that we have all of these new integrations and use cases well documented and explained?
We have a solution in OCM repo. It has some detailed steps of how you can set up the environment.
Okay. Could you please send up a PR for Q repository so that we have cross links?
Yeah, I think yeah, so do you mean we can put our solution in queue also?
Yeah, so not necessarily like copy this entirely, but On queue documentation page, it would be great if we could have a link to your work. So if someone is interested in queue and by accident is using OCM, then they can get there from OCM. Or if they are evaluating just queue, maybe they would like to have OCM as well. Anyway, probably your work would benefit if we could cross-link it.
Oh, yeah, that's great. Thank you.
And one more thing, do you have any feature requests for multi-queue coming from your setup? Or are there any pain points that you would like to have fixed or anything like that?
Oh, yeah, yeah, that's also one thing we want to discuss with you because we want to know your the molecules direction or your thought on do you think this integration makes sense? And
Uh,
yeah.
Well, all integrations uh, make sense. So OCM is valuable project, so we are happy that someone documented how to integrate it. Uh, Maybe we could provide some better APIs for modifying queues or including altering the placement in some way. So we would happily listen to your feedback of what could be made better from the OCM perspective.
Yeah,
Yeah.
maybe we can start with what you suggested to put our solutions in queue also, and since all our code are still in local, we not pushed to community yet. If you think it's fine, I think we can refine that part and maybe add more requirements we can raise to multi-queue.
Cool. Looking forward to seeing it.
Yeah, thank you.
Thank you.
King, do you have any plan or timelines in terms of when you plan to make this public? I think you said it is kind of on your local repository. Do you plan to push it all the way to some, a repository where everyone can contribute to it?
Do you mean contribute to which repo?
To currently, I think the state is that you mentioned that it's currently in a local repository, and OCM is basically OCM is a local repository. You have plans of either moving it under, you know, CNCF or Q, or what are your plans on that sense?
Oh, for the what do you mean?
So sorry.
Yeah.
OCM is a CNCF sandbox project, so it's
Ah,
not a local repository, it's a public repository. So
okay.
everything is public.
Perfect. Thanks for clarifying that. I think that's something I missed. Okay. Any other questions for King? Ahmad has his hand raised.
Hi, thanks for the demo. It was really useful. Just a quick question. Since OCM is vendor neutral, so probably there are multiple vendors implementing OCM itself or providing the OCM APIs. Does that mean that for an implementation or a provider to comply with OCM, do they also need to support Q implementation or integration?
No, so Q for the OCM is integration. Like OCM is just to provide some multi-cluster management API and how you can manage the multi-cluster. And there's some integration that we did before, like Argo and Q and some other project. That's mostly like Q. We think the Q is basically a multi-Q is a consumer of the OCM to utilize some approach that OCM have to easy to make the setup of the multi-queue easier and for the scheduling benefits. So there isn't any strict requirement that you don't need to use either of that.
Okay, thank you.
Kevin has his hand raised. I'm not sure. Mihal has his hand raised as well. I'm not sure
I
about the
think
order.
Mihal is
Okay.
first.
Yeah, go on, Mihal.
I have a question about the admission check that you implemented to support the integration. So I'm wondering how closely coupled is the admission check to OCM, and if this is something you would consider upstreaming to Q, like so that the admission check is probably opt-in, but closer to multi-queue, or it has like a lot of OCM specific code so that it's not so easy to decouple.
I think the current external admin check controller is based on the OCM's placement and placement decision.
I see. So it's rather closely coupled to the placement. And okay, so then to compile it, you would need to see the whole OCM. So it's probably belonging to the OCM repository. I was thinking along the lines like on Marcin's idea of how to separate the concerns, and wondering maybe the admission check could be put upstream. So still something in the air, but yeah, I got my answer. Thanks.
Thank you.
Kevin, you're next.
Yeah, I guess I was curious on, so next steps for you all are, I guess, calling out this integration in Q, but then for the OCM community, what kind of support are you planning to provide for the emission controller? Because I imagine it's a custom controller, and like, will this be part of an OCM release?
Yeah, currently it's not in, but we hope we could have put it into the OCM release. So that's a reason that we want to ask about like is there any plan for the like multi-queue scheduling in the queue community? So as you see today, the implementation is like we have a SASC admission, and that will update the clusters, like the queue clusters, based on the placement decision. But if there's any plan on the scheduling things on the multi-queue, we probably will need to also adjust the current solution. So really depends on how the plan for the queue and how we can integrate in the future.
So if I understand your question, you're asking more about like kind of the roadmap for multi-queue and how like how these two can continue to be supported.
Yes, like the roadmap and how is there any discussion about scheduling, any plan for more advanced scheduling in the for the multi-queue part?
Okay, maybe I can take this one. So in multi-queue, the actual scheduling is done by worker clusters. So multi-queue will not change that. What we are currently thinking about is deciding which cluster to start first and which should come second. Right now, multi-queue puts every workload to every cluster available, hoping for the best. Possibly starting in for a moment in multiple clusters, and then it will resolve and only one will be left running. However, it might be possible that some clusters are somewhat more preferred than the others and should be attempted first, and only if they don't succeed for a period of time, the others should be given a chance. So while we don't have any proposals yet, this is like an option to influence scheduling that probably will come in near future. So the ability to integrate with something external that will provide you like a deployment plan. So start with cluster B and then wait for maybe 20 minutes. And if the workload is not admitted, then proceed with cluster A and C and keep the B still being attempted, or maybe stop attempting B then and use A and C as fallbacks. So we don't have it yet fully hammered out, but that's a rough idea what could possibly go next. If you have any other ideas or you have some opinions on what should be added, please let us know. We definitely want to hear your feedback.
Yeah, okay, thank you. That's quite good information.
I don't see any hands raised. Do we have any other questions? Okay, looks like we can call it a meeting. Thank you so much, King, for presenting and sharing with us OCM. Have a great rest of the day, everyone. Take care. See you all in 2 weeks.
Bye-bye.
Thank you. Bye.